In this video, we are going to be doing 4 different questions on trig functions. All right, let's jump in. So for question 1, there it says, find the equation of the graph. We can definitely do that. So let's go make sense of what's going on. It is always a good idea, grade 10s, to have an understanding of your basic graphs, your basic sine graph, your basic cos graph, and then your basic tan graph. Now, I think you would agree with me that we can eliminate the tan graph for this one. That is definitely not a tan graph. It's always a good idea to understand and know your basic graph. So since we are starting by the point 0, 0, and we start by increasing, I would say sine graph. What do you think? Because our basic sine graph starts by 0, goes up, turns at 90, cuts by 1, cuts by 180, turns by 270 and 1, goes up to 360. And so that's the period is 360. And if I look at that, if I compare it to my basic graph, I can clearly see that there was a stretch because now my maximum is by 2 and my minimum is by negative 2. So how does that affect our graph? Well, our transformations for our sine graph, it means that we can change this value, which is the vertical stretch, and then this one is moving it up or down. Do you think it moved up or down? I don't think so, because it still starts by 0, and I like to look at this, that the middle of the graph is still there, meaning that the distance to that and the distance to that is the same. Okay, so we need to find out what that A value is. Since there is a stretch that my maximum is by 2 and my minimum is by 2, I would say that my A value is equal to 2. How can we also work that out? So taking your max, subtracting your minimum, and dividing that by 2. That will also always give you that A value. Your maximum is by 2. Your minimum is by negative 2. Just watch your substitution there, which would give us 4 divided by 2, and that also gives us 2. Great. So we already have the A value. And we need to consider the Q value. The Q value is moving it up or down. Now, we already identified that the middle of the graph is still where it is for our basic graph. So the graph didn't move up or down. So our Q value will just be 0. So therefore, I feel like I'm so messy with this question. So our A is y is equal to 2 sine x and then plus 0. It didn't move up or down. Let's see for B. What is the amplitude of the graph? Well, our A value gives us what our amplitude is, but let's just refresh our memory on what our amplitude is. The amplitude represents a distance from the middle of the graph, so like the equilibrium of the graph, to the maximum point of the graph, which is over there. So the distance from there to there is 2 units. And then from the middle of the graph to the minimum point, which is there by negative 2, is also 2 units. So it means the amplitude is 2 units. Your amplitude will always have a positive value because it refers to a distance, but this normally gives you that. All right, let's look at C. What is the period of the graph? Well, we need to know this. The period of the graph is 360 degrees. What is that again? The period of the graph is not how long, how many degrees does the graph need to complete a curve? So our sine graph does this, and it keeps going, right? I know that's not the prettiest graph that you've seen, but it keeps going. It starts by increasing, turns, cuts, turn, cuts, and then that curve starts repeating itself. Same curve, and then it starts repeating itself. How many degrees does it need to repeat itself like that? And it is 360 degrees. Let's head over to question 2. Question 2, find the equation of the graph. Okay, I think we can eliminate the tan graph. So we need to consider whether this is a sine graph that has been transformed, because that's definitely not our basic sine graph, or we need to consider if this is our cos graph. Well, I'm going to go draw in my sine graph quickly. It starts by 0, goes up, cuts, turn, cut. All right, so if we were to move this one down, it would be like that. So that's definitely not what happened with this one. And if we, I don't know, shall we rather consider a cos graph first? What do we know about a cos graph? We know that the cos graph starts there by 0 and 1, cuts, turns, cuts, turn. So to this side, it will look like that. All right, so that looks better. That looks like something that we could work with because where our basic graph is there, all the values for our graph that we look at is negative. So where our graph starts by -1, by 0 degrees and -1, our basic cos graph starts by 1. So how is our basic graph transformed? So that instead of by 1, it starts by -1. It must be a negative a value, a -1 a value, where it is a mirror image about the x-axis. So it is a reflection about the x-axis. All those values there are now there. So that must be a negative value. And do check out the previous video if you feel like that doesn't make sense to you. And then did it move up or down? Great tense? I don't think so, because I just looked to see if the middle of the graph is still the middle of the graph. It's also a good idea to work in pencil when we scribble on these things, that we can get rid of it when it gets a bit messy. So the middle of the graph is still the x-axis. The distance from there to there is 1. The distance from there to there is 1. So it definitely didn't move up or down. So our Q value is still just 0. So we don't even have to write that. So that is our answer for A. Y is equal to negative cos x. Let's look at B. The amplitude. We spoke about the amplitude with the previous one, where we said that that always refers to the distance from the middle of the graph, so like the equilibrium to the maximum, which is just 1 unit. We already saw that. And the minimum is just 1 unit. So our amplitude is 1 unit. I know we said that these two are the same, but just make sure that your amplitude must always be a positive because it refers to a distance. Let's look at C. Period. What is the period? What is the period of this graph? So how many degrees? How many degrees do we need to complete one of these curves? So however you prefer to look at this, we can say, okay, let's start looking at that. So we go down, 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 down. And then at that point, it will start repeating itself, right? So how many degrees do we need for a curve to repeat itself? Well, it is 180 degrees and then 180 more. So it is 360 degrees. How can we also look at this? Well, I mean, we can just go start there and see, okay, we go up, turn, down, and then at that point, it's going to start repeating itself. So we need 360 degrees. So our period for our cos graph is 360 degrees. Find the equation of the graph. I'm sure that we'll agree that we need to consider a tan graph for this one, where we've got some asymptotes. Notice there by 90 degrees and 270 degrees and by negative 90 degrees. That is an asymptote. The graph does not exist there. What we need to consider is, did this graph transform in any way? So is there an A value that we need to consider? Was there a vertical stretch, in other words? And then did this graph move up or down? Well, if we consider great tens our Q value, I would say yes, that it moved down because we need to know our basic tan graph, y equal to tan x, starts by 0 and then it starts by increasing. So the fact that this one starts there by -1 tells me that surely it must have moved 1 down. Now we need to think about this A value. For our tan graph, we don't have an amplitude, we don't have a minimum and a maximum. Let's look at that A value. Well, in the previous video, I just also brought it to your attention that the point 45 degrees and 1 is a very important point. So if we are by 45 degrees and 1, then it means the A value is 1. If we are by 45 degrees and 2, it means that the A value is 2. Okay, but now we need to consider that we moved it 1 down. So our basic graph will be 0 and then go up and cut by 45 and 1. But this whole graph moved 1 down. So it cuts by 45 and 0. So it means that our A value didn't change. Our A value is still by 1. Because, let me just say that again. Our basic graph is by 0 and then 45 and 1. But the fact that we moved it 1 down, because the Q value is 1, and the fact that it is now by 45 and 0, it means that the A value didn't change. Because if the A value changed, it wouldn't have been there. I hope that makes sense. And also just refer to the previous video if you feel like it's a little bit confusing. So A is equal to, in this case, 1 for A, and then tan x, and then we moved it 1 down. That is A. Let's look at B. What is the period of the graph? We need to know what that means. How many degrees does a curve need to complete itself? Our tan graph is different to our sine and our cos graph. So for this curve, we need how many degrees? 90 and 90 more. We need 180. And this curve, same story. How many degrees do we need? 90 and 90 more. So the period for our tan graph is 180 degrees. C. Write down the equations of the asymptotes where x is between 360 and negative 180. So basically, they're just telling us that we need to look at the asymptotes that is on the graph in front of us there, because it's already the domain negative 180 to 360. So let's go write down those equations. There's an asymptote. Sorry for that ugly scribble. There's an asymptote, and then is an asymptote. But now we can't just go write down negative 90, 90, and 270. They asked us specifically to write down the equations of those asymptotes. So this is the line x is equal to negative 90. This is the line x is equal to 90. That's what they mean when they say write down this equation. So there would be our answer. X is equal to negative 90 degrees. That's my one asymptote. Also where x is 90 is an asymptote, and x is equal to 270, and there's my asymptote. We also looked at those equations of vertical lines for our function section, so refer back to that if you feel like you need a refresher. Last question. Find the equations of the following function. So we've got those two graphs there, and we need to find the equations, and then for each graph we need to state the domain and the range. We learned about this idea when we did functions. So let's look at the first one there. I think we can definitely rule out a tan graph for this one. I'm going to go draw just a rough sketch of my basic sine graph, which starts by 0, up, turns, cuts, turns. Okay, so there's my basic sine graph. So if I look at this, to me, it looks like this one just moved up with 2 units. So that point moved up 1, 2. 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 Yeah, so I'm pretty convinced that this is a sine graph that moved up. Did the amplitude change? No, but how can we also prove that? We just quickly take the maximum, which is by 3. We subtract the minimum, which is by 1, right? And then we divide that by 2. So it gives us 1. So the A value did not change. All right, so we got the equation for this one. This has the equation y is equal to sine x, and then it moved 2 units up. There's the equation. Let's quickly write down the domain. So for the domain, grade 10s, we go look at our x values, right? We go look at our x values, so we're going to go position ourselves on the x-axis, and then we're going to see where the graph exists. If there is a solution for y there. So if we position ourselves anywhere on the x-axis, so I'm going to go position myself there, then I go towards the graph. Yes, there is a solution there, so it's part of my domain. If I go there, yes, there's a solution there, the graph exists, so it's part of my domain. Part of my domain, you get the picture, part of my domain, because the graph exists there. There aren't any restrictions. So that must mean for our domain, let me just move this up slightly. So for our domain, it would be that x can be between 360, so it must be smaller than 360, but it must be bigger than 0. And I am including my 0 and my 360 because there are solutions there. Some of you might write it slightly different. Some of you might write it as x is an element of including 0 and then going to 360, perfectly fine. How else? No, that's all I can think of right now. So that would be the domain. Let's go look at the range. So for the range, we need to consider our y values. So now we are going to go position ourselves on the y-axis and anywhere on the y-axis, and we're going to go towards the graph. If a solution exists there, if the graph exists there, then it's part of our range. So if I go position myself there, yes, there's a solution there. The graph exists there. If I go there, because remember, we are positioning ourselves on the y-axis now for the range. So if I'm there and I go to the graph, yes, it exists. It exists. It exists. Ooh, not anymore. So not part of the range. Let's go down a bit. The graph exists. There's a solution for my x. The graph exists. Yes. Yes. No, not anymore. So my range is from where to where? Well, there, anything above 3, it doesn't exist anymore. And anything below 1, it doesn't exist anymore. So what is my range? My range is between my y must be smaller or equal to 3, but my y must be bigger or smaller than 1. How would some of you also write that? Y is an element of, we are including 1 and then 3. So the graph basically exists between 1 and 3 for my y values. Let's look at the next one. Let's find the equation for that. I think we can again rule out our tan graph. Let's first start and consider if this is a sine graph. I'm going to go draw my basic sine graph in 0, turn, cut, turn, cut. Does it look like a sine graph to you? I think, shall we? I know my curve isn't very pretty, but I think we need to consider the cos graph as well before we start working on that one. My cos graph starts there, cuts, turns, cuts, turn. And then obviously it will cut, turn. I think there's a resemblance there. There was just a vertical stretch and it also moved down. Let's investigate why I'm saying that and see if you can agree with me. Well, the x-axis is always, like for the basic graph, the middle of the graph, right? But that's not the middle of the graph anymore because it seems like this is now the middle of the graph. Let's think about if we look at that pink graph. Do you see what I mean? Because the distance from there to there and the distance from there to there is the same. So it looks like it moved down. So it looked like it moved down. If I see where the middle of the graph is now, it looked like it moved down with 1. Okay, but if it moved down with 1, if we look at our basic graph, it should have started by 0. So why is it still starting by 1? Surely there must be an amplitude change. Let me just clean this up a little bit. Let's go check what the A value is. We take the max and we subtract the minimum and we divide it by 2. That gives us 4 divided by 2, which gives us 2. So that gives us that our A value is 2. So there was a vertical stretch of 2 units. So how can we also check it on the graph? The middle of the graph is now there, so it moved 1 unit down. But the distance from the equilibrium, the middle of the graph, to the maximum is 1, 2. And the distance from the equilibrium to the minimum is 1, 2. So it does mean that our A value is 2 units. So however you figure that out. But if we took grade 10's the basic tan graph, the basic cos graph, and we stretched it and we made the A value 2, for the basic graph, it would have then started at 2, go down by -2, cut, go up to negative 2. Oops, that is not supposed to happen. I'm sorry. By 2, cut, turn, cut, turn. I feel like I'm very messy today. I'm really sorry. And then cut, turn. So then our maximum would be by 2 and our minimum would be by 2. But now can you see that yes, the stretch is 2, but then we moved it 1 down, 1 down. So this would be the equation. Y is equal to 2 cos x, but we moved it 1 down. That was quite tricky. It's good though. So however you figure it out, if you do it completely different to the way I do it, that's perfectly fine. There's often many different ways of looking at it. Okay, now we need to go write down that domain for this graph. So for the domain, we are going to go position ourselves anywhere on the x-axis, and we go towards the graph. So x-axis, yes, the graph exists there. There's a y solution there. So then it's part of my domain. Yes, yes, it's part of my domain. If I go there, yes, yes, if I go there, there's no restrictions on my domain. So my x, well, they did give us a restriction in terms of like we're only working between negative 180 and 360, so we just need to consider that. I almost said x is an element of real numbers, which is kind of true if this curve carried on and on and on and on and on and on, but they just limited us with this one. So x must be smaller or equal to 360, and x must be bigger or equal to 180. How could you have also written that? X is an element of including negative 180. Remember, the smallest number must go first. And there we go. Let's look at the range. For the range, we are going to go position ourselves on the y-axis. We're going to go towards the graph and see if there's a solution. Does the graph exist there? So if we start there by 0, well, yeah, the graph definitely exists there. And there, yes, most definitely, yes, it does. Oh, when we reach that point, the graph does not exist there. There's not an x solution for that y. So where does the graph kind of stop existing? There, where y is negative 3. Hey. Then, if we move up, yes, there's solutions there up to that point. Anywhere over 1, there aren't any more solutions. So our graph, our range is between those two values. Our negative 3 must be smaller or equal to y, and y must be smaller or equal to 1. How could you have also written that? Y is an element of including the negative 3 because there is a solution there going all the way to positive 1, including that, and that would be my range. Great, teens, go try some of these on your own now that it's fresh in your memory, and I know that you can figure this out.